everybody, welcome to the lecture on weathering soil and unstable slopes. When we're talking about unstable slopes, all we're talking about are different types of ways that land can slide, basically. So we're talking about landslides, and that's what the images are we have here. This is from a 2010 landslide outside of Taiwan. And you can see just how devastating and expensive and dangerous these kind of mass movements of land can be. So in this chapter we're going to introduce the processes and landscape expression of weathering, the process of soil development and general features of soils, factors that control slope stability and the types of slope failures, so different types of landslides and rock falls, mudslides, those types of things, and the impact of those slope failures on society. So the places that people have chosen to build their cities are pretty specific for different reasons. So if we take a look at this example of Caracas, just look around for where you see people are building. What types of slopes are they building on? Okay, you can see that people are mostly living along the coast. So think about the geologic settings of these towns. Why do you think they were built where they were? Typically they're built on flat areas. The flat areas are at the foot of valleys and are fan-shaped. So think about what's going on there. And many of the areas here are just too steep to build on, so people chose to live down in the valley. And if you think about the way water falls, it's all going to flow downhill. So it's to your advantage to live in these low, flat areas. However, sometimes it's at a great disadvantage to live in those low, flat areas, especially if you're surrounded by so many steep slopes in an area that gets plenty of rainfall. So particularly in 1999, this became a huge problem. We can see we've got landslide scars all over these slopes showing where the surface has given way in the past, and we have alluvial fans, and so that just means we've got a sort of a constant feed of sediment coming down off of these steep slopes. So again, in 1999, this caused a particular problem, to say the least. It caused landslides on hills, and that fed debris flows down the canyon. So a debris flow is like a river of rocks and mud and trees, whatever it picks up, eventually houses, cars. So it almost behaves like a mini tsunami, just carrying everything. So the debris flow carried car-sized boulders into town and just plowed over everything. It destroyed entire neighborhoods, and sadly it killed 19,000 people. The USGS and Venezuelan geologists discovered houses built on older debris flows with huge boulders, which tells us that this has happened in the past. And if we had properly studied the area before it had all of this development occur, we could have seen, okay, this is not a safe place to build. This place is susceptible to these very large landslides and debris flows, and they could have taken different measures to try and either stabilize slopes, build so that they could resist some sort of landslide event, which is less likely, or just not build there in the first place because they know that it's a dangerous area. All right, the role of joints in weathering. So when a large body of rock breaks or fractures, we describe those as joints. So pre-existing joints form from burial, tectonics, and cooling. Okay, so what I mean by that, burial, is just the pressure of additional rocks on top of whichever rock is being jointed or fractured. Tectonics would be the tectonic force of the plates moving around, and that's strong enough to fracture rocks. And then cooling. Sometimes you get joints forming from cooling. If you think about what happens when you throw hot water on a icy windshield, right? I don't know who's done that. Unfortunately, I have. That's what I get for being a desert rat. I didn't know what to do. So you throw hot water on a cold windshield and it will fracture. It will break all over the place. It's the same idea if you have very hot rocks cooling off rapidly. That drastic change in temperature can fracture the rocks. Okay, the next example is expansion joints. So if you're stretching out the area tectonically, right, if we have tension in that area, that can give you expansion joints. Also, if you're just bringing rocks up to the surface that had been at depth, that rock can expand. And sometimes that expands in the form of unloading. So that's what this bottom image is. Unloading is where sheets of rock peel off. And that's just, again, from uplift. So you get less pressure, and that is called exfoliation when it has that texture of breaking off. It's almost like the whole hillside is sort of flaking off, and it forms these round structures. So the role of joints in weathering is that rocks fracture in response to weathering. Joints are fractures or cracks in rocks that show no significant offset. So it's not the same as a fault. There's no movement. It's just breaking the rock apart. Joints help break rocks into smaller pieces because they permit water and roots to penetrate into the rock, and so they increase the amount of weathering possible. So the surface area that's exposed to weathering increases as that rock is jointed or fractured further. Here we're just looking at how much jointing is going on, the spacing of the joints, and what exfoliation looks like. So in the upper left, we're looking at the Connecticut Valley with the amount of jointing. So we've got fractures going in opposite directions. You can see that these would be, the main joints are facing southeast and northwest, but then we also have perpendicular jointing going on in that image. And then in the image in the bottom left, looking at the spacing of the joints, primarily we're looking at the top rock unit, and we can see we've got columns of rock that used to be one massive piece of rock, but it has just been jointed to look like it's got these vertical columns. And then lastly, we're looking at exposed rock in Yosemite National Park, and this is showing us exfoliation joints. So again, it looks as if you're peeling the rock away, and what ends up happening is you form these large rounded structures. So you may have seen these driving around in different areas. California has a lot of them, southeast Arizona. A lot of areas with granite that's weathering will give you these big, rounded, weathered structures as a result of exfoliation joints. So joints greatly influence how a landscape develops. Joints affect the strength of the rock, its resistance to weathering and erosion, and they influence how pieces of rock are pried loose from the landscape. So the process of jointing allows greater weathering. It speeds up the process, it breaks the rock into smaller pieces, and it weakens the rock. So what are the processes involved there? When we're talking about breaking rocks into smaller pieces physically, what we're talking about is physical weathering. So the different types of physical weathering we have, starting in the upper left, heating and cooling. So as temperatures get very cold at night and very hot during the day, repeated over thousands to millions of years, that can weaken the rock and can actually cause it to break apart. So in the past, some geologists have discounted that concept, but recent studies are showing that it plays quite a role in physically weathering rocks and breaking them into smaller pieces. The next one is frost wedging. So what happens with frost wedging is water flows into a fracture in a rock, and then it freezes. And when it freezes, it expands. So think about putting a water bottle or a soda bottle or can into the freezer. What happens? Right? That frozen fluid takes up more space. So it will break the bottle or break the can. You'll have a huge mess. But in the case of frost wedging, what it does is it actually breaks the rock. So it may just be a tiny amount, but over many, many years, it builds up and you can get serious fractures and breaking apart of rocks as a result of frost wedging. So a similar concept is mineral wedging. If you've got mineral-rich water flowing into fractures, then a lot of times those minerals will precipitate, so they will crystallize inside the fracture, and when they do that, they can push that fracture further apart. So they're actually prying open these fractures in the rock as the crystals of the minerals are growing. Okay. Next we have root wedging, and all that is plant roots forcing their way through, typically finding a weak spot in the rock and pushing its way through, prying that rock apart. Okay. And then perhaps the most obvious one is burrowing animals. As they burrow or dig through sediment, they can dig through soft rock. They are physically breaking those rocks apart. So joints are formed by various processes at depth and by expansion of the rock near the surface. They play a major role in weathering, but other physical weathering processes also mechanically break the rock into smaller pieces. So those are all of the processes we just talked about: the heating and cooling, frost wedging, mineral wedging, root wedging, and burrowing animals. We said jointing and fracturing increases surface area. Let's prove that to ourselves. So we have a cube here, and in each dimension we're looking at 2 centimeters. So if we're looking for the surface area of just one side, then we would multiply 2 centimeters by 2 centimeters to get 4 centimeters squared. Right? This is a 6-sided shape, right? It's a cube. So then we take the surface area of our one side and multiply that by 6. So 4 centimeters squared times 6 sides equals 24 centimeters squared. Okay. In contrast, if we then took that cube and broke it into pieces, if we just halved it in each direction, and each cube was 1 centimeter in each dimension, one side would be 1 centimeter cubed, 1 centimeter squared. And then if we multiply that by 6 sides and multiply that by 8 cubes, that gives us a surface area of 48 centimeters squared. So we have more surface that is exposed to water, to air, to roots, to mineral wedging, to frost wedging. So we've increased the surface area that can be exposed to be weathered. So fracturing increases surface area, greatly increasing the exposed surfaces, providing more area that weathering can work on to further break the rock down.